So if you did what you were told to do, you have already worked in your groups on these problems and given it your best shot. So now I will talk about them. So suppose these are all going to be quadratic application problems. Suppose an object is dropped from a height h naught in AUGHT, which is like the initial height, above the ground. Then its height after t seconds is given by h equals, and I like to use actually h of t since height is a function of time, negative 16t squared plus h naught, where h is measured in feet. Use this information to solve the problem. Now, think about what, this is a constant, the h naught. Think about what kind of function this is. Okay, well, when you look at this as it's t squared instead of x squared, but it has a negative. So right away, you should realize I am dealing with an upside down, with a parabola that opens down. So if a ball is dropped from 288 feet above the ground, so they're telling you that this is h naught, how long does it take to reach ground level? So they're telling you that h of t equals negative 16t squared plus 288. And when they ask you how long does it take to reach ground level, well, you are talking about they're asking you about the time, and you got to think about what ground level means. What is the height if it's at ground level? Well, hopefully you recognize that the height is 0. So they're asking you for what time is h of t equal to 0. So that's what they're asking. So when you're doing an application problem, you have to kind of look beyond, you got to look at the words and think, what are they mathematically asking me to do? And that's what it is. So they're asking you to solve this and you can do this fairly easily with your, using your calculator. But I'm not going to go through all the calculations. But I would on this one, I would subtract 288. I would divide by negative 16. I would square root both sides. Remember, when you square root both sides, you get plus or minus, but you can't have negative time. So that is going to tell you the time when the height is 0. So that's what you do for 83. On number 84, a ball is dropped from the top of a building 96 feet tall. So they're telling you h naught is 96 feet. How long will it take to fall half the distance to ground level? So now I know h of t equals negative 16t squared plus 96. So if you are dropping it from 96 feet and you want to know when it falls half the distance, you have to know what is half of 96. So half of 96 is 48. So they're asking you, when is the height 48? So you have to think about how you do that. Well, how do you solve quadratic equations? You get it equal to 0. So we're going to have to do 96 minus 48, which is 48. I'm going to go ahead and move this to the left side. What did I say it was, though? Plus 48 equals 0. And you can solve that, and you can find out what that time is the same way. How long will it take to fall to ground level? So again, to fall to ground level, the height would be 0. So we would be looking at negative 16t squared plus 96 equals 0 if you want to find when it hits ground level. So this one's not so bad. On the next problem, we're doing they give us the formula. You didn't have an example 7, but they tell us this formula. And again, I'm going to call it h of t is negative 16t squared plus v naught is the initial velocity. So a ball is thrown straight upward at an initial speed or velocity of 40 feet per second. So now I know that my function, h of t, is negative 16t squared plus 40t. And we're going to be asked some questions. When does the ball reach a height of 24 feet? So you're going to set your equation equal to 24 feet. And you have to solve this for t. This one's a little more involved because when you subtract 24 from both sides, you get negative 16t squared plus 40t minus 24 equals 0. So we're solving this quadratic equation. I happen to notice that I can pull a 4 out of, I can pull an 8 out of this. And I'm going to pull out a negative 8 because I'd rather this be a positive t squared when I'm solving this. So this is going to make this a 2t squared minus 5t plus 3 equals 0. Okay, notice if I distribute the negative 8, I'd have what I started with up here. Now, next I'm going to divide both sides by negative 8, which really means the negative 8 doesn't matter. So I get 2t squared minus 5t plus 3 equals 0. I'm pretty sure this factors. This is what I do when, because 2 is prime, the only way I can get 2t squared is 2t times t. The only way I can get 3 is 3 times 1. I need a negative 5 in the middle. So I think this is going to be negative and this is going to be positive. And you can FOIL that and see how that works. So I, not really guess and check because I knew there were only 2t squared. That's the only option, 2t times t, and 3, the only option is 3 times 1. So I'm really just kind of thinking about where, positive or negative and where they would go. If I set this equal to 0, 2t plus 1 equals 0 means t equals negative 1/2. If you solve that, t minus 3 equals 0 means t equals 3. The question, when does the ball reach a height of 24 feet? Well, it can't happen then because we can't have negative seconds ago. In 3 seconds after the ball is thrown. When does it reach a height of 48 feet? You're going to do the same kind of thing. I'm not going to go through that one, but you would do the same thing. This would be a 48. Notice that when you do that, you have a new equation to solve, so you got to go through all the work again. What is the greatest height reached by the ball? And then the next question, when does the ball reach the highest point? Well, remember that our initial formula was showing us a negative t squared. So we're looking at something like this. Well, think about where the greatest height is. It's going to happen right here at the vertex. So if you remember, we had a little formula to find the vertex. The x-coordinate was the opposite of b over 2a. So that's what you're going to make use of to find the greatest. Actually, you're going to end up doing the when part. You're going to do part D before you do part C, because if you find, and I probably shouldn't call it H since I was going to call it HK, but since we have H for height, I'm not going to call it that. But to find the vertex, we're going to take the opposite of b over 2a. So b is 40, so I get negative 40 over 2 times negative 16, which is negative 32. So when I simplify that, I'm going to get a positive 5/4, because 8 goes into both of those. That's the x-coordinate, or the t-coordinate. So this is the time. So this is actually 5/4 of a second is actually my answer to part D. And then if I want to know, well, what is the height at that time, because that's going to be the greatest height, then you're going to plug that into the function. You're going to find h of 5/4 and plug that in here for the t and the t in both spots. And I'll let you do that. I'm not going to do that. And then number 86, how fast would a ball have to be thrown upward to reach a maximum height of 100 feet? So on that one, I'm actually going to leave that one off because I really wanted us to focus on those other ones. And so we're going to stop there.